This is a NEET 2016 question from the wave optics, basing on a concept of interference and Young's double slit experiment in particular. The question says, the interference pattern obtained with two coherent sources light sources of intensity ratio n. He mean to say there are two sources used, the ratio of that intensity I1 by I2 equal to n. In the interference pattern, what is the ratio of I maximum minus I minimum by I maximum plus I minimum in terms of this given data, that is n. So first of all, when the two waves are met, resultant amplitude can be written like A1 square plus A2 square plus 2A1 A2 cos theta, because they are in the format of a vector, where A1 and A2 are the respective amplitudes of two sources. And we also know that intensity is proportional to square of amplitude. So if we eliminate proportionality, we can write directly amplitude square. So A resultant means it can be it's actually a resultant square, because resultant of two vectors R can be written like root of P square plus Q square plus 2pq cos theta. In the place of P, you write first amplitude and then second amplitude plus 2A1 A2 cos theta equal to resultant amplitude. You square this, A resultant square equal to A1 square plus A2 square plus 2A1 A2 cos theta. Intensity is directly proportional to square of amplitude. So in the place of A resultant square, I can write I resultant equal to I1 plus I2 plus 2. The place of amplitude, I can write square root of intensity cos theta. So for maximum, this theta becomes 0, because cos 0 equal to 1. Then I resultant becomes I1 plus I2 plus 2 root I1 I2, that is root I1 plus root I2 whole square. You just square this, you will get back this, that is I maximum. I minimum, theta becomes 180 root I1 minus root I2 whole square. So that's where he is saying what is I maximum minus I minimum, right? So I can write from here, I can continue my derivation and write this value, I maximum minus I minimum by I maximum plus I minimum is how much? I maximum means root I1 plus root I2 whole square minus root I1 minus root I2 whole square, that is I minimum, this is this minus, by root I1 plus root I2 whole square. Instead of minus, I have to write plus as per the question. But ratios of intensities is given for you. So I can rewrite this as root of I1 by I2 plus 1 whole square minus I1 by I2 minus 1 whole square by, instead of minus in the denominator I will get plus I1 plus I2 plus 1 whole square plus square root of I1 by I2 minus 1 whole square. Now I1 by I2 is given in the problem as n. So this will become root n plus 1 whole square root n minus 1 whole square by root n plus 1 whole square plus root n minus 1 whole square. So if you simplify this, root n square is n, a plus b whole square, a square plus b square plus 2ab plus 1 plus 2 root n minus n plus 1 minus 2 root n, because it's a minus b whole square. The same n plus 1 plus 2 root n plus n plus 1 minus 2 root n. Here 2 root n will cancel. Here it is n plus 1 plus 2 written, minus of is there, this is minus of, so it becomes minus n minus 1 plus 2 root n by n plus n is 2n, 1 plus 1 is 2. So this n and 1 gets cancels. What is remaining is 2 root n and another 2 root n, 4 root n by 2n plus 2. So if you try to simplify that further, the answer is 4 root n by, let us take a 2 common in the denominator, n plus 1, this becomes 2. So 2 root n by n plus 1 is I maximum minus I minimum by I maximum plus I minimum. That shall be my answer. Option B is available as an answer, right? That's how we have to solve this problem. So to solve this problem, we shall have an idea of finding out resultant amplitude and then resultant intensity and expressing them in terms of ratios of intensities as n, that is given in the problem. That's how we have to solve this problem. Thank you for watching.